Hello everyone, today I will show the design of steam oil. Here is the example or steam oil design. So at first we will read the questions. The design of steam oil of cantilever retaining wall. Steam oil of the retaining wall. So at the support of bank of earth which is 20 feet height and the top of the earth is below with a surcharge of 500 psf given that angle which is 33 degree allowable soil bearing capacity 4 ksf frequency 3.5 ksi and fy 60 ksi and soil unit weight of soil 11a psf and groundwater level and 10 feet below the top of the height. There is the ground level is 10 feet below. Okay, so at first we will calculate the h prime. H prime is here, we have seen here, which is called surface divided by soil unit weight of soil and found 4.23. Here is the 4.23 feet and active pressure K equal to 1 minus sin phi into divided by 1 plus sin phi, which is 0.26, and pressure of horizontal of steam pH. So there will be divided two portion 1 and portion 2. As we have seen, the water pressure is above the 10 feet of the steam. So P dry soil and P moist soil. Here is a dry soil and two portion is moist saturated soil. K gamma D into H. Here is a D into H is very important. Gamma dry, we have known the unit weight of soil 118 psf. On the other hand, H we have used the upper portion of the retaining wall, which is 10 into 4.23. So 14.23 and saturated soil K is also 0.23 into gamma prime will be soil unit weight of soil divided minus pore water pressure. Pore water pressure is 62.5. We all know the unit weight of water is 62.4 and H2 will be 10 feet and we have found 0.53 kip per feet square. And horizontal force on steam, we will take a 1 feet of steam, that's why we will multiply 1 and the convert the unit will be 0.518 kip per feet. On the other hand, we have shown the pressure was kip per feet square and the horizontal force is converted only 1 feet of steam and convert the unit kip per feet. And the design load to 1.2 plus dead load plus 1.6 live load. There is no live load. If the water will be only water or dam will be designed, then we can multiply 1.6 live load. Live load is only for water. So take a note about this. If we design the dam or then we have to multiply 1.6 into live load. Live load is water. So there is no water. We have seen the all the portion have filled in soil. Even the soil is pore water pressure is 10 feet above the steam wall. Okay, there is no purely water. So is all the soil, even dense soil or saturated soil. But if all things are soil, not water. This is the dry soil and this is the saturated soil. But we don't think this is the only water. No, there is the saturated soil. If the all the portion is belong to water, then we will just take in the 1.6 live load which is water. I hope that you can understand. When you see that dam, then you can see the only there is no soil beneath the steam wall. That's why we can use in when we will design this dam, then we will use only water for light. Okay, so the design load is 0.697 kip per feet and analysis will be here. We can see the reaction is we have found the load is here. Here is a 0 and another we have found 0.697 and we know the the load is acting as a triangular. So seen the triangular load is here 1/3. If we calculate from here, then it will be 2/3. So 1/3. Sorry, it will not 1/3. So we can assume that the basic formula of triangle, half into length into height. So half into length, the length is here and height is here. So 24, half into length to 0.697 and height 24.23. Here is the 24, 10, 10 and plus 4.23. So 24.23, which is 8.44 kg. And we have, if we the load is applied is here, acting as in the here. If we want to find out the moment, then we have to calculate this force from this point is 1/3, and from, if we calculate this here, then 2/3. So that's why we have used 1/3. 1/3 into h is here, and r. Okay, we have found here r, and 1/3 of h here. Or we can write the full formula of r, but we will not do this. Rather than we will use 1/3 of h into r, which is here, and we have found 68.17 cubic feet. This is our moment. So we will design for this moment. So this is the very important to find the moment. So you have to understand that is why we have used 1/3, because we are calculating the moment from this point. That's why we have taken 1/3. Otherwise we will take the 2/3 if we calculate the upper portion, but it is not possible. Okay, so let's try the depth check. Here is the thumb rule. We have found depth equal to h by 8, and this formula is taken from the load book of Nadim. So Nadim Hussain, if you search in Google or internet the RC design of Nadim, then you can find easily the book of Nadim. Here is the formula. So our respected teacher also learn us how to calculate depth. So I have found the depth is 36.34 inches, and by now if we want to do the shear check, then we will check the shear. Here is the diagram will be shear. So shear diagram will be triangular here. We know that this is B max, and all the depth is h. We all know all the depth is h, and this is the d, and upper portion will be h minus d, and in the d will be sequence at the point of BD. So B max divided by d, which is B max, and divided by h. H is total height. Here is the total height is h, and B max is the maximum maximum force. On the other hand, we have seen B into BD. Here is a BD, and h minus d. H minus d is the upper portion. So this is the similar triangle equation. So we can use when we will compare the bigger portion, then we will take the larger height. When we take the smaller horizontal distance, then we will take the small horizontal. This is the only similar triangle formula we have used. Here B max is the design load 0.637, and BD is here, and we have put in the value and found this is calculation. On the other hand, we have seen the resisting capacity. We know 0.17 root over F times CBD, and found 0.09 into T. So equation 1 and equation 2, we will solve this and found 7.5 inches. And we have found here the another calculation 36.4 inches by thumb rule or from Nadim. And on the other hand, we have found from shear check D is 0.75. So we can conclude that we will use 30.36. We can use the depth. So depth means we can we don't think this is the depth. Rather we are using the steam. Steam is here portion. So depth will be here. This is the 36.34 inches. Here is the 34.36. So don't forget or don't puzzling of this. This is the depth as we are calculating of the steam. We are already shown that we are calculating the steam. Okay, let's find out the reinforcement. As we know, as equal to Fy Fy F prime C A P, and found putting this below and found 1.64 as, and as equal to M divided by 5 Fy D minus A by 2, and putting the value and found 0.42 inches square. On the other hand, we have found the minimum reinforcement 200 divided by Fy into BD and found 1.42, and we have found calculating 0.42. So we'll take the maximum value from this for taking the safe zone. So we will use the 1.42 inches square, and we have using number 7 bar, which is 0.66 inches square, and number of bar is needed on 0.15 into 0.60, which is 3 for per feet. 3 per feet we have to write the only 3 bar will be used per feet, but we don't need it or calculate. Rather than we will use the spacing of bar as equal to 12 divided by s and found 5 inches square center by center. So we can conclude that the number 7 bar at the rate of 5 inches center by center to be used as a particle bar. This is the main reinforcement bar. Here is a particle bar. Here is a particle bar. As a particle bar. As a particle bar. We will use this portion where the soil is rest. So take a note this. There is the soil. So we will use this portion particle bar in this side. Not the other side like this. So we will use this particle bar for where this side of soil is rest. On the other hand, the horizontal bar, which is taken for minimum reinforcement, which is 3 root over FMC PT or 200 FYPT. So we will take the maximum, which is from, we have found 0.3 inches square and 0.2 inches square, but we will take the 0.3 inches square as this value is maximum. So we have used number 4 bar, and the area of 4 bar is 0.19 inches square, and we don't need the number of 4 bar. Is 2 bar per feet, but we don't need it. We will not calculate it. Rather we will use the spacing of bar as into 12 divided by s, which is 7.6 inches square center by center. So we can write number 4 by at the rate of 7 inches center by center. So one thing is that so I want to mark this color. So this is our horizontal bar. Here is the horizontal bar. Here is the horizontal bar. We have used number 4 bar center by center in where the soil is rest. Here is the soil portion. But we will how we will calculate the another side like this. So another side will be minimum reinforcement, which we have used as minimum. So the as minimum is same as the 0.4 into 7 square is number 4 bar at the 7.6 inches square center to center. So this minimum reinforcement will be the opposite side of the wall where there is no soil is resting in the retaining. So I hope that you can understand. So if I conclude this, then we can see again that I will say we will use the steam of cantilevered retaining wall. So at first we will find the H prime, which is surface divided by soil pressure, and we will take it the pressure will be divided two portion as we have shown. There is a dry soil and saturated soil. If there is no saturated, then we will use the dry soil. But in practically, we will calculate all the soil is saturated. That will be very fine for we will take the conservative sites. So this is our pressure and finding putting this value and found 0.518 kg per feet square, but we will multiply is one will take the 1 feet of a strip. That's why we will found the 0.58 kg per feet, and design load will be 1.2 dead load only, because the soil is resting. If there is no soil or we will calculate the only dam, then we can use 1.6 into live load. Live load, where we will find the live load comes for water. As there is no water or dam design, then we will not use. And found 0.697, and analysis will be same like half in triangular formula r, half into length into height. Then we will found r, and movement will be found 1/3 of the r, 1/3 h into r, right? And this is our movement. And the depth check, I have already said that this is from the formula comes from Nadim Hussein books RC. And we can also share check and found the depth. The two type of depth we have found, one is share check, another is now Nadim. That's why we will take the 36.34. The depth is here 36.4, not the base, because we are calculating the steam. This is called steam, and this is called base. Okay, so design reinforcement is calculating here. We will use this 0.16 into S and putting this below 0.49, and minimum reinforcement found is 1.49, 1.45. So we will calculate the 1.45, and spacing will be number 7 by 5 inches center by center. So this is our main reinforcement, which will use in vertically, not horizontally. Horizontally, reinforcement bar has used the minimum reinforcement. So minimum reinforcement bar is horizontal, but on the other hand, we can use the opposite side of the bar, which is here. This is also the minimum reinforcement bar. So I hope that you can understand. If you have any question, then let me know. Thank you.